Hi, this is Denise, and today I'm going to be performing the baking soda rocket. I'm going to go ahead and perform the actual lab and then discuss what takes place after. I do apologize. I do live in Los Angeles, so it gets pretty noisy out here. Today I have pre-filled my vinegar inside my bottle already prepped with my pencils. Uh, Taped on. My baking soda is already inside of a little napkin, and I do have my cork ready. So I'm going to quickly try to prep this and we'll discuss what takes place after. Okay. My cork. My baking soda is inside this wrapped paper towel. I'm going to go ahead and drop it inside the vinegar. Ooh, so there definitely was an explosion. Okay, so I think for mine, what went wrong is not only did it fall, unfortunately I can't perform the experiment again just because in LA we have low supplies on a lot of the stuff that we have, and that includes like even baking soda that was so hard for me to find today, and the vinegar as well. But for mine, maybe the cork didn't fit fully, which I should have tested ahead of time. But what should have happened is that the rocket should have went up definitely in the air. Um, we saw that when you mix the vinegar and the baking soda, there was a lot of bubbling and foaming. The bubbles and foam are filled with carbon dioxide, CO2 gas that's being released by an acid-base reaction. And the vinegar is an acidic acid dissolved in water. And baking soda is a base called sodium bicarbonate. So initially, the reaction makes carbonic acid, which is unstable. It quickly breaks down the CO2 and water, and the gas then rapidly leaves the water, creating foam and bubbles along the way. When you close the bottle with the cork, like I did, you prevent the CO2 from escaping the bottle. This causes rapid increase of pressure inside the bottle, and the pressure eventually gets to the point that the rubber, in my case, the cork, that the cork basically helps pressurize the bottle, and the pressure eventually gets to the point where there's a rapid increase in that pressure inside the bottle, and it's not allowing that CO2 to escape. So that's when the explosion is supposed to take place. In my case, you could still see the actual reaction take place as you saw the bottle tip over, and I attempted to re-put the cork in it. You can tell that there was a slight reaction there, so I am happy that that did take place. um, and the contents inside basically exploded, and it didn't take that long either. So as the contents of the bottle shoot downwards as I flipped it over, and that's when it actually spilled out, I think, because the pressure from the water and then hitting the cork that didn't fit so well just caused it to actually spill out and tilt to the side, unfortunately. So as the contents of the bottle shoot downward, the bottle itself shoots upward. So there's supposed to be an opposite reaction. And usually when that was supposed to take place, that would have been actually a really awesome example of Newton's law of the third law of motion, which is for every action there is an equal but opposite reaction. And the initial action is the rush of materials and force out of the opening, going one way and pushing hard against the air behind the bottle. And the reaction is the air pushing back with the same amount of force going the other way. So the bottle should have thrusted forward, and causing that foam rush and gas shoot backwards. So thank you so much, Professor, for watching. I do apologize for the tip over, but I did still get the chance to see the reaction did take place. Unfortunately, it just didn't lift off. Thank you. Happy Halloween, and God bless.